So say we're given two vectors, u1, u2, u3, v1, v2, v3. Dot product is defined to be the sum of the products of the components, the corresponding components. Right, so u dot v is u1 v1 plus u2 v2 plus u3 v3. We extend this to any size vectors. Right. All you do is multiply corresponding components, add them together. What kind of quantity is that? What kind of quantity is this? Oh, you have two types of quantities. It's a scalar, isn't it? Dot product is also sometimes called the scalar product, because it results in a scalar. So properties of the dot product. Let's say we have three vectors, u, v, and w, some scalar c. The dot product is commutative. The order in which you do it doesn't matter. That is fairly simple to prove. Dot product distributes across vector addition. The order in which you do a scalar multiplication does not matter. This is the associativity property. So how you group the scalar multiplication is irrelevant. Again, it's a very useful property, especially when dealing with vectors with very large components or very small components. And the property of magnitude, v dot v, is the magnitude of v squared. As a corollary to the third property, if you take the dot product of two scalar multiples, you can multiply the two scalars together. take the dot product of the vectors and then multiply the results. And again, this can extend to, actually, no, it can't. You can't have a triple dot product, right? U dot V dot W is undefined, because that'd be a scalar dotted with a vector, which doesn't exist. Can't do that.
You might explain that again, because I didn't understand this.
What part?
How can we multiply a scalar?
So dot product is between two vectors. You can't do a scalar dot a vector. That's undefined. Right? And of course, if you take the dot product of two vectors, you get a scalar. So that's why you can't do something like U dot V dot W. An alternative form to the dot product, U dot V is the magnitude of U times the magnitude of V times cosine of the angle between the vectors U and V. So let's say we're given there's vector U. We're going to draw the two vectors in such a way that their initial points are the same. That would be the angle between them. What are the possible values for theta? And so the vectors of facing the same direction of the angle B. Now they face opposite directions. What's the angle?
What?
In radians. So obviously it's going to take then all the values from there. But what happens? Instead, let's say it's now something like this.
Still less than 180, it gives you the smallest angle between the two.
Now you're measuring the angle this way instead. So the possible values for theta, 0 to pi. Zero means they point in the same direction. Pi means they're pointing in opposite directions. What if the angle is pi over 2?
The dot product is 0.
That's definitely true. But what about the vectors? What can you say about the vectors?
They're perpendicular.
Perpendicular. And we don't like that terminology when we're dealing with vectors. You'll learn why in linear algebra when we get to more general vectors. You already know the answer, don't cheat. We say orthogonal when we deal with vectors. There's actually three ways to say forming a right angle. There's perpendicular, there's orthogonal, then there's one more. You should know it. Normal. We typically only say normal when we're dealing with a plane or a surface. But I could say that two vectors that are perpendicular are normal to each other. They all mean the same thing, and they are used interchangeably. So get used to the language. Well, think about it, right? Your three standard unit vectors, I, J, K, well, they're vectors. So if you have any vector u, you can find an angle between those three vectors, right? Those are the direction angles. Right, so we have three angles that are formed from a non-zero vector and the coordinate axes, x, y, and z, the I hat, j hat, k hat. Cosines of these angles are called the direction cosines. So you have a vector in space. Alpha is the angle that the vector makes with respect to the positive x-axis. Beta is the angle the vector makes with respect to the positive y-axis. And gamma is the angle that the vector makes with respect to the positive z-axis. Remember correctly, we'll look at the equations in an example problem. Vector projection of V onto U is the vector that has the same initial point as U and V and the same direction of U. Represents the component of V that acts in the direction of U. Useful when we're dealing with forces. Right, you have a car parked on an incline. What's the component of gravity acting along the incline? That's the projection. Right, so remember, gravity always acts straight down, but you're now on an incline, so you're no longer acting straight down. There's a force of gravity acting in the direction of the incline, which is the force that you would need to overcome to go up, if we ignore friction. Length of this vector is the scalar projection of V onto U. Projection of V onto U. Keep this order in mind. U dot V over the magnitude of U squared times U. Scalar projection, component of V onto U. It's just the magnitude of that previous vector, which if you take the magnitude, you're going to wind up with U dot V over U, or just V cosine of theta. All right, remember, U dot V is already a scalar. So you take the magnitude of a scalar, you just get the absolute value of that scalar. So actually, that should be an absolute value, shouldn't it? Should it? Yeah, that should be, shouldn't it? Dot product can be negative. Let's fix that. The physics definition of work. The energy required for a force to move an object. There are 4 scenarios. First one's the easiest. One-dimensional. So you move an object along a straight line with constant force. Then your work is just the force times the distance. Second scenario, still one-dimensional, so straight line. But now the force varies, typically as a function of position. Work is then the integral over the interval of your force. You should have studied those two in Calc 2. Now let's move it's not one-dimensional, so you're not moving along a line. You're moving along a path. again, you're going to have two scenarios. One, your force is constant or a function of only one variable, so typically time. Then it's just F dot, your position vector. I'm sorry, no, it's not. That's if position is a directed line segment and constant force. Think if you have the varied forces, you're going to have to do an integral again. Think that is the integral of F dot. All right, so this is if your force is constant. And it's a directed line segment. If your force is variable, so your force varies, it becomes a line integral, which we studied at the end of the semester. Even if your path isn't a directed line segment, you have constant force, but your path is no longer a directed line segment, it's an actual path, it's still a line integral. So that incorporates those other two possibilities. Force varies with respect to one variable, or you're moving through a force field, which is the most common case. Right? Earth has a gravity field. Trying to find work, it's a line integral. Moving through an electric field, line integral. Here we're just stick with the simple. Force is constant and you're moving in a line, given by a directed line segment. Want to resolve the vector A into parallel and perpendicular components with respect to B. This idea is extremely important in the study of physics. You have two components of motion, the tangential and the normal. So being able to do that. The parallel component is just the component of A that's acting in the same direction as B. Or possibly the opposite direction, but it's parallel. It's typically represented as A parallel. that is the projection. Projection of A onto B. So I said you have to pay attention to the order. B dot A over B squared times the vector B. What is that dot product? 3 times 4 plus 1 times 3. What is the magnitude of B?
Square root of 3 squared plus 1 squared.
Which is what?
No, 10. Square root of 10.
Root 10 squared is 10. 15 over 10, 3 halves. That would be our parallel component. Perpendicular component. This one's nice and simple. A minus the parallel component. Because A has to be the sum of the two, the parallel and the perpendicular. So A was 4, 3. Four minus 9 halves.
Negative 1.
3 minus 3 halves. And there's your perpendicular component. Work done in moving an object along the vector A with an applied force of F. That's easy. Not F, sorry, W. Before we even continue, does that make sense? Is work a vector or a scalar? Work is a scalar. It is strictly a scalar. So, yes, the dot product does make sense. What's that dot product?
6 4 or 6 plus 4 10.
Standard units for work. So we'll start with force and position. Standard units for position is what?
Meters.
Hmm?
Meters.
Meters. What is the standard unit for force?
Newtons.
And what is the newton?
The force required to accelerate 1 kilogram by 1 meter per second squared.
You said acceleration wrong. We write m over s to the second power, but that's not what it actually is. It's meters per second per second. It's a very common misconception. Because remember, acceleration is a rate of change. It's the rate of change of velocity with respect to time. The rates of change are always units of the numerator per units of the denominator. So dv dt, units of v, meters per second, units of t, second. Meters per second per second. Yeah, so the newton is the kilogram times meter per second per second. Standard unit for work is then what?
Joule.
It's the joule, a newton meter. But joule is also the standard unit for what? Any kind of energy. Kinetic energy, potential energy, heat energy. It's all joules. That means work is energy. Work is a measure of energy. There's another unit for energy.
Is it watt?
Watt is intensity. The calorie. calories are also energy. So that's also very commonly used, but for different reasons. Right? We don't use calorie when we're dealing with physics, but whenever you deal with health science, it's always calories. But it's still energy.
I think in Europe they do use like joules for the energy.
They might. I'm actually not sure how Europe works. We should convert to the SI as well, to be honest. That'd be fun, change all of the road signs from miles per hour to kilometers per second. Or kilometers per hour, I think they use. Which is shameful because that's not SI. SI would be kilometers per second. I think we're the only country in the world now that uses still the empirical units. There was one other country, but early 2000s they adopted the SI.
There's some like random islands that use it.
Then they're American territories. So we have to be the weird ones. Angle between OP and OQ. What does O represent? The origin. That makes the directed line segments very easy to find, right? So what's OP? What about OQ?
-3, -1.
Draw vectors for that easy. Angle between them, how are we going to find it?
Inverse.
Use the alternative form of dot product. What's the alternative form of the dot product? U dot V equals what?
The magnitude of U and V.
That it. Where theta is what?
0 to pi.
What does theta measure?
The angle between
Angle between
the two vectors.
U and V. Oh, that's what we're trying to find, isn't it? There's your formula for the angle between two vectors. Cosine theta is U dot V over UV. Magnitude of U times magnitude of V. Since theta is between 0 and pi, can we safely take the inverse cosine? Yes. Range of the inverse cosine is 0 to pi. What's that dot product?
-7.
Magnitude of u.
Square root of 15.
Magnitude of v. You get -7/14, -1/2. Theta is then the inverse cosine of -1/2. What's theta?
Pi over 3. 2 pi over 3.
Units. It's a trick question. Technically, it has no units. Radians are unitless. We don't write 2 pi over 3 radians. It's just 2 pi over 3. The only reason we use radians as a unit is if you're looking at rate of change of an angle. It's kind of weird to write like 2 pi over 3 per second. So we say radians per second because that sounds better. But technically speaking, it is just per second. Oh, the nuances. All right, we're given a triangle. We're pretending that that is three-dimensional triangle. We're using our imagination. We want to find the angle of alpha. Or not of alpha. We want to find that angle alpha. How would you do it?
What are the angles between directed line segments AC and AB?
And what's the formula then?
It'd be it'd be line segment AB dot AC over the magnitude of AB times magnitude of AC.
What does that equal?
No separate.
Well, not theta.
Up goes that.
In this case, it'd be alpha. Write AB in component form.
Is AB 1, negative 1, 0?
Are you asking me, or are you telling me that's what it is?
Telling me.
Say it with more confidence.
AB is 1, negative 1, 0.
What is AC? What is it? That's not good. What is that dot product? What was it? What is the magnitude of 1, negative 1, 0? What is the magnitude of negative 3, 1, negative 1? $11.
Root 11.
How's the denominator simplified? What is it?
2 radians.
What was it? Root 2? Yes. Just square root of 22. Is that acceptable?
That's all teacher.
It is unless you're
Unless you're a what?
a nerd. Or you could
I don't know what nerd wouldn't find that acceptable.
Radical over bottom.
Yeah, what nerd wouldn't find that acceptable?
I'm middle school math teacher.
They're not nerds. Every nerd I know would leave it that way. Because that's how we keep it in a lot of the sciences, specifically physics. We don't rationalize that. It's too much work. You got bigger problems. Like trying to solve the mystery of the universe. Or writing up a good game. Although now a lot of nerds are trying to do AI chatbots. How does that simplify? You're in the wrong school. Your Tumblr doesn't match.
Yes.
Yeah, wrong
Yeah,
school.
I know. It's from 2 years ago. Still keep it for full time.
I know Vrone's in the name, but it's
Yeah.
different school. I thought Tumblr's not even the right colors either. It's supposed to be red and white.
They don't even mix it up.
Don't even have the right symbol on there. They don't have their school logo on there. I also work there. That's how I know that.
Oh, nice.
We'd have heard you teach calculus down here. Because I'm from Mercedes, yeah, I've seen.
Regular semesters I only teach online. They don't pay me enough to drive out to campus.
Go Professor Cooper.
Heard of them, don't know.
I had him too.
Yes.
I really only know one professor there as a friend. Watchford.
Oh.
How's that simplify? It's taking you too long. That is its simplified form. So you're done. Remember, never give me a decimal approximation unless I specifically ask for one. The answer is always going to be exact form. I can't tell you how many people that's cost an A. Because they gave me the decimal approximation instead of exact form.
Do you ever ask for one?
Sometimes. Direction angles for the vector 3, 12, 4. Foam sounds like a good color. So we're going to start with this. Right, we already know that. So using that, cosine of alpha, what does alpha measure?
Angle with respect to the x-axis.
And what vector represents the x-axis?
3, 0.
1, 0, 0.
So I'll just write it as I hat. But as you just said, I hat is what? 1, 0, 0. What happens when you take the dot product of a vector with I hat? Ignore the specific vector A, just in general, take a general vector. What happens when you dot that with I hat?
It's the projection onto the x-axis.
True, but that's too complicated. There's a much simpler way of saying it.
Just a scalar.
We get the value of x.
It's the x component. Call that base of x. That's just the first component of A. What's the magnitude of I hat? 1. What's 1 times anything? Itself. So there's cosine of alpha. It's just going to wind up being the x component of your vector divided by the magnitude of the vector. What does beta measure?
Y.
Y.
So it'd be A dot what?
J hat.
What happens when you take a vector and dot it with j hat?
You get the Y component.
What's the magnitude of j hat?
Just A.
1.
I wonder what this one's going to be. What does gamma measure?
C.
So it's A dot what?
K
Okay.
hat.
What happens when you dot a vector with k hat?
Good C comp.
What is the magnitude of k hat? There are your 3 direction angles, or direction cosines rather, for any vector. Right, which means that alpha would be the inverse cosine of the x component. What is the magnitude of A? What was it? How does that simplify?
It doesn't.
It doesn't. Beta is the inverse cosine of what?
12 over 13.
And gamma is the inverse cosine of what?
4
There are your 3 direction angles. Shit, lost track of time. Too much fun. So plenty of time now. 4 minutes. Determine the value of k so that these 2 vectors are orthogonal. What does it mean to be orthogonal?
90 degrees.
Perpendicular.
Angle between them is 9 degrees. What about the dot product?
0.
So this is what we're solving. Two plus 3k minus 8 is 0. 3k minus 6 is 0, right? What's k? There you go. K has to be 2 in order for these 2 vectors to be orthogonal. We want a unit vector orthogonal to both u and v. go about this
Cross product.
using the operations that we've learned? So you can't use cross product yet. Bummer, right? Well, first step would be to find a vector orthogonal to both of them, right? And then just normalize it. Call that vector W. W would have to satisfy both of those equations. So say W is X, Y, Z. U dot W would be what? What is it? That has to equal 0. What about V dot W?
4x 25 minus.
And that has to be 0. Oh, that's a system of equations. Except that we can't assume linear algebra. So, nope, you don't get to do that. You have to use the methods of just plain old algebra, method of elimination. Or calculator. Calculators can solve systems. At least the one that I'm requiring can. It's not too difficult to solve. If we do 2 times the second equation plus the first, that'll get rid of the y's. 10x, that's gone, -2. (10x minus 5z) is 0. If we divide everything by 5, z would be 2x. Let's plug that in to either of the 2 equations. Let's plug it into the second one. You get 4x minus 2x is just 2x. Solve for y in terms of x. So W is any vector of that form. X can be anything. Let X be 3. Y is then -2, and Z is 6. There's a vector orthogonal to both. Normalize it. Six and 4 is 40, 49, so 1/7. There's your vector. I actually could have left some of this for tomorrow. I forgot. I didn't have to finish dot product. That's okay. Maybe we'll have some free time on Friday then. First web assigned homework is due the 31st, don't forget. Second one, I don't have set to go up until Thursday. Second one covers dot products. And don't forget about your first project. See you on Thursday.